Yeah, in today's video we're going to do exercise 5.9, I believe. Let's just check. Yeah, 5.9. So generate primes. So what we're giving is we're given a number, and let's say this number is 7, and we need to generate all the primes, right? So our output would be 2, 3, 5, 7 in this case. Cool. So this is expected output. So one way of solving this would be to create an array of Boolean values, and we initialize it by so let's just write indices 0, 1, 2, 3, 7. Cool. And all of the values are at first truthy values, right? Cool. Now we know that 0 and 1 are not truthy, so we can set them to false, right? And now what we do is we just go from 2 onwards, and we can have results variable that has just an array, and every time we see the truthy value, this current number, we just append the current index to the results variable. So this integer here is prime, right? So let's just append it. And now what we do is for these values, we need to set them to false values, right? Okay, so multiplications of these current integers. So 2 times 2 is 4, so this number is not a prime, right? 2 times 3 is 6, so this number is also not a prime. And we're at the end array, so we're done here, right? We can move on. So we are at index 3. 3 is truthy value, so we can append this 3 to our results variable, and we need to handle the next integers. So 3 times 2 is 6, and it's already false, right? Next time, so we're here, we see that 4 is false, so it's not prime. We can move on. 5, it's true, let's append 5, and so on until we get to the end, and we have our results, right? Cool. So let's talk about time specs complexity for this one, for this solution. So time is actually, it's n square for this solution, because every time for each number we need to traverse the whole array, and for space we're creating an additional list, so it's of n, and n is actually corresponds to this number. Cool. So let's write a solution for this guy. Generate primes. We are giving an n, and we need to return a list of primes. So we know if n is less than 2, we know that we don't have any primes, so we can just return empty list. Cool. And now if n is larger, so we can say, okay, we have candidates. This will be all a Boolean array, right? So all the values will be truthy times n plus 1. Cool. We also have results variable, and now all we need to do is just loop over for I in range. So we start from 2, because numbers below 2 are not primes, until the length of candidates. Yeah, So right here we're in for loop. We know that if the current I is not prime, we can just move to the next integer. So let's do this check. If not, so the current index is not prime, we can just continue to the next number, right? If not, if it's prime, let's first append this number, so I. And next thing we need to do is make it bigger. Next thing we need to do is mark additional values from I, so multiplications of I, to set to false. So those numbers are not prime numbers. So let's do this next. So for j in range, and we start from I till candidate, and step can also be I, right? And we just mark, this is j, to false. Cool. After we're done with this, we can just return result, right? Let's quickly implement this in code and run the test so we know if our solution is correct. So if n is less than 2, we know that we don't have any prime, so we can just return empty array. Now we know that we have some primes, so let's have a results variable that it's set to empty array, and candidates, which is array of Boolean values. If the current value is not a prime, let's just continue to the next value, next integer. If it is, what we can do is first append this current index and mark the multiplication of this number to false. Start with step is also I. Just quickly check the code. Here returning empty array. We loop over each index, continue if it's not candidate, appending, it looks alright, and the test pass. Yeah, thanks for watching. I hope this video helped you in some way, and until next time, bye.